In this enterprise network grid, a single point of failure in the data center can trigger a systemic collapse. Watch as these active nodes transition to a failed state. This downward trajectory represents an idled workforce and a massive loss in hourly revenue. Many professionals assume the crisis is managed once the physical servers are rebuilt. Rebuilding hardware takes time that a hemorrhaging business does not have. Operational survival must take precedence over technical restoration. This is the role of business continuity planning, or BCP. It is a strategic framework designed to ensure the organization functions during and after a disaster. Standard cybersecurity controls are preventative. BCP is what happens when those controls have been completely bypassed and the infrastructure is lost. If your systems are impenetrable, but the organization cannot generate revenue or serve its clients, the security architecture has failed its primary objective. CISSP candidates often struggle because they conflate business continuity with disaster recovery. Disaster recovery planning is a tactical operation focused on the restoration of technology and infrastructure. As this matrix shows, business continuity planning is a strategic effort to maintain essential services and the overall function of the organization. The DRP column highlights the technical work, rebuilding servers, restoring code, and fixing damaged hardware. On the right, BCP manages the human and financial elements. It ensures payroll continues, manages public relations, and establishes manual workarounds for the staff. DRP is actually a subset of BCP. It solves the technical problem of how we restore the technology. The larger BCP framework dictates how the company keeps operating while that technology is being rebuilt. The foundational CISSP rule is that technology serves the business. The business does not exist to serve the technology. Executive management prioritizes BCP because technical restoration is irrelevant if the company goes bankrupt during the outage. During a disaster, an organization lacks the resources to save every department at once. The Business Impact Analysis, or BIA, is the analytical tool used to solve this prioritization problem. This flowchart shows various departments funneled into the BIA filter. This process identifies which specific functions are truly critical to organizational survival. Inside the filter, the BIA quantifies operational impacts, regulatory fines, and the hard financial consequences of downtime. An internal email system going offline for a few hours typically results in a low priority ranking. In contrast, a hospital's patient monitoring network is a high-speed priority. The BIA routes it to the top because the impact of failure is immediate and catastrophic. The final result is a ranked list of recovery priorities. This list dictates where money, personnel, and effort are deployed first. Without a BIA, disaster response relies on guesswork. Teams often waste energy on highly visible technical issues while ignoring the critical systems that actually keep the company alive. Once the priorities are set, management applies mathematical limits to the recovery process. These limits are defined by the recovery time objective and the recovery point objective. On this timeline, the vertical marker in the center represents the disaster event. Moving forward in time from the event is the recovery time objective, or RTO. This is the absolute maximum acceptable downtime for a system. The RTO measures how long the business can survive without the function before the damage becomes irreversible. Looking backward from the event is the recovery point objective, or RPO. This measures the maximum acceptable data loss. The RPO directly dictates backup frequency. A 1-hour RPO requires the organization to back up data at least every hour. For the CISSP exam, remember that RTO measures forward downtime, while RPO measures backward data loss. Defining these quantitative limits transforms a crisis into a measured engineering problem. After establishing the metrics, the organization formalizes the business continuity plan. The document includes non-technical components like communication protocols, regulatory notifications, and the location of alternate work sites. A plan that has never been tested is worthless. This gauge represents test rigor. Testing must scale in complexity to be effective. Checklist reviews and tabletop exercises occupy the lower zones. These validate document accuracy and allow teams to discuss hypothetical scenarios in a controlled environment. The upper zones involve simulation exercises and full operational tests. These execute recovery procedures in realistic, disruptive environments to see how the system handles actual pressure. A test's primary value lies in its ability to expose hidden flaws and weaknesses before a real disaster strikes. Resilience is discovered when a plan breaks during a test, allowing management to fix the vulnerabilities before the stakes are real. Returning to the initial scenario, the data center is destroyed. Because a BCP is active, glowing lines route operations around the failed core to alternate hubs. The BIA prioritized assets, and RTO/RPO defined the thresholds. The business stays alive while IT begins the DRP. To pass the CISSP, you must adopt the perspective of an executive risk manager rather than a technician. Mastery of this domain means recognizing that while technology is expendable, the survival of the business is absolute.